Good morning or good afternoon, depending on where you are. My name is Kathy Kroll. I'm the co-director of technology transfer for the IBT ABC UTC at Florida International University. I'll be moderating today's webinar. We'd like to thank you and roughly 600 other registrants for joining us today for our 168th webinar in our monthly webinar series. Today's featured presentation is Sprayable UHPC. We'll be learning about Virginia DOT's abutment repair and the development of mobile capabilities. Sam Falaha and Dr. Atorad Azizamini will be our featured presenters. With that, we'll start with a few announcements and then move into the presentation that will last approximately 35 to 40 minutes. The presentation will be followed by a question and answer session. Thank you again to those who joined us for the 2024 World Bridge Engineering Conference in Miami in December. This is a biannual event with the next conference scheduled for December 1st and 2nd of 2026. It will also be in Miami, Florida. Please mark your calendars. We have a few upcoming events to highlight from our industry partners. First, the American Institute of Steel Construction, the National Steel Bridge Alliance, will be hosting the Steel Conference that will include the World Steel Bridge Symposium. This event is in Louisville, Kentucky from April 2nd to the 4th. See the links on the screen for further information. Next, the American Composite Manufacturing Association is hosting the Design Using Pultrusion Technology Conference in Chicago, Illinois from May 6th through the 8th. See the link on the screen for further information. Next, AASHTO's Committee on Bridges and Structures will be holding their annual conference in Dallas, Texas from June 1st through June 5th. Registration is open and information can be found at the links on the screen. Now, for a few events from the IBT ABC UTC, the next monthly webinar will be on Thursday, April 17th from 1 to 2:15 Eastern. The featured presentation will be on the I-95 bridge collapse in Philadelphia. You may remember that this bridge was in the news as there was an oil truck that exploded under the bridge. This presentation will be on how PennDOT was able to restore traffic and replace the bridge extraordinarily quickly through innovative ideas and excellent teamwork. Please mark your calendars to join us for this interesting presentation again on April 17th. Our next quarterly research seminar is scheduled for April 25th from 1 to 2:15 Eastern. The featured project is Transformative Bridge Asset Management using an Integrated Graph Network (RNN) approach. This seminar will be presented by our partners at the University of Florida. Before we dive into our featured presentation, I'll go through a few housekeeping events. As many of you may know, these webinars are recorded and posted on the IBT ABC UTC website in the section titled Monthly Webinar Archives. So you can access this and all previous webinars for future learning and to share with interested colleagues. I'd also like to point out that a PDF version of today's presentation is provided in the GoTo dashboard on the right side of your screen. You can download these PDFs during the training session. They'll also be posted in the archives. Lastly, the presentation will be followed by approximately 15 minutes of question and answer. Please enter any questions you have in the question box in the GoTo dashboard. With that, we will begin our featured presentation. We welcome Sam Falaha, who is the Northern Virginia District Bridge Engineer with the Virginia Department of Transportation, and Dr. Atorad Azizamini, who is the Director of the IBT ABC UTC and Professor at FIU. Thank you both for sharing your time and expertise with us today. With that, I turn it over to Sam and Atorad.
Well, good morning, and thanks for the opportunity for this presentation. We'll start the presentation by Sam Falaha. But before we start, I also wanted to say Happy New Year to those of you who are celebrating the Nowruz or Eid. So today is a very special day, so very happy New Year and happy Nowruz. So with that, let me ask Sam, would you like to start the few slides?
Certainly, thank you. Good day to all those attending, and welcome to this presentation and training. So the presentation, I guess let me start saying thank you for the introduction, and thank you, Kathy. The presentation centers around the sprayable or the spray applied UHPC. A couple years back, I met Dr. Azizi at the TRB, and he was discussing the innovations at FIU. And one of the innovations that he mentioned was the sprayable UHPC. And as part of the discussion, I offered that we try it because we have numerous candidates that would benefit from this technology. So that conversation led us to a demonstration project, and that we will be talking about here shortly. So the presentation outline is VDOT's objectives for utilizing spray applied UHPC, a little bit about the project details, introduction to UHPC, properties of UHPC. I will present some of those, and again, Dr. Azizi will carry on with the rest of it. And then, of course, number 5 would be the summary of activities leading to repair of the bridge at the bridge abutment in Virginia. Number 6 would be lesson learned, and then followed with future plans. Next slide, please. So the bridge is located on the ramp, we call it ramp H, and that is from I-495 to US 50 interchange. Now, the 495 is the beltway around Washington, DC, and this bridge is approximately 16 miles from the White House, if you will. And from the District of Columbia. Next slide, please. So as you can see in the picture, it's a very busy and congested area where the 495 is a main thoroughfare, the beltway around Washington, DC, and the ramp is ramp H from US 50, which is another busy thoroughfare. So the bridge was built in 1985, and the deck and the superstructure are in good condition. The substructure is in fair condition, and you can see the pictures here. Next slide, please. So as you approach the bridge, and you could look at the abutments as circled, or in the red square, the areas of the repair, one on the left and one on the right. And these are symptoms of leaky joints, where the icing salts causes corrosion and spalling of the concrete. And this is exactly what happened in this case. And of course, if we repair those abutments, being vertical wall, the repair usually either involves adding concrete cast in place, which means usually when you want to add concrete, minimum of 4 to 6 inches, which is significant weight and significant effort. And of course, it adds dead load to the substructure and the foundation, or spray applied or shotcreting, where you can apply a thin layer to provide the protection. And in this case, UHPC will provide the protection and restore the durability of the abutment. Next slide, please. So again, this is close-up of the repair, and you could see the spalls where the corrosion of the reinforcement is visible. As preparation to the spray applied, we removed all the loose and delaminated, and of course sandblast or pressure wash depending on the case. And in this case, it was a sandblast to remove all the loose and all the corrosive material or corroded steel residues. And this is obviously a preservation action where preserve the bridge for the long term. Next slide, please. So this is a close-up after the preparation, where you could see all the loose and all the damaged material has been removed. The steel is exposed, and the bridge is ready to receive the spray-applied UHPC. And again, one of the main issues, or one of the main preparation, is saturated surface dry, where the concrete is prepared to receive the spray applied UHPC. Next slide, please. So here are pictures of the application, where you have a man lift with the equipment ready for the application. So originally we had one side as a trial test, and the other side was supposed to be the actual repair, but we ended up switching around due to the traffic control. So the quantities of the material, because the material was brought from FIU on a truck with all that, was not enough to do the entire repair. However, it was good enough to show that the repair is actually works, and the spray applied UHPC is a good technology that will provide the protection needed, as well as the restoration of the bridge to serviceable condition. At this point, next slide, please. So it would be noteworthy that the FHWA published the EDC, in the EDC News Innovation of the Month, the ultra high performance concrete spray applied or sprayable, and it was published on February 6th. For your reference, if you would like to look it up and read it. It's a very good technology for the applications that we're referring to. Next slide, please. So with that, I will hand it over to Dr. Azizi. Dr. Azizi.
Okay, and Sam, thanks a lot, by the way, for our audiences. Sam managed to somehow, I guess, break his wrist. So we really, he was say thank you to take some time before actually he had the doctor appointment. So, but he said that he's going to be with us at least the first 50 minutes and then basically leave. So, Sam, thanks for taking time.
Thank you. And I just like to say that this is an important topic that I strongly believe in. So with that, I'll hand it back to you. Thank you.
Thank you, sir. All right. So I'll go on with the rest of that. And by the way, here is also Jamal El-Qasaid is one of the actually a moderator in the question and answer period with FHWA. And FHWA actually was present in the field when we did this project, and the article that Sam is referring to, the February 6, 2025, is really summarizes this project, the story that I'm going to tell you. And by the way, the Jamal Aksai, he's been wonderful working with us at the IBTA, VCUTC. So Jamal, thanks for all the efforts that the FHWA has contributed to success of these projects. So let me go on with the rest of the presentation. Before I start, I wanted to just show you some basics, some introduction to ultra performance concrete. The slides that I'm showing you are borrowed from a good friend of mine, Eugene Gruweiler in Switzerland. So a few years ago, I traveled to Switzerland, and Eugene showed me some of the projects that they've been doing for over last, actually now about 20 years, that they have used the UHPC for, they don't call it retrofit really, they call it upgrade. Because the reason for that is because this material is so strong, so durable, that the end product is better than the original structure itself. So that's why in Switzerland, they refer to this as a means and material that you can be using to upgrade existing deficient structures. So these are some of the examples that they showed me, and I borrowed this slide from Eugene Bruwider. One of the examples that to me that was very interesting was on the left-hand side, you see actually a pool. The liner is made out of the UHPC. You can see at the edge, actually at the edge, that you can see this ultra-performance concrete. And they are storing a hazardous material. So I will show you some results. Actually, the rapid chloride permeability number, the number of the Coulomb for this material is very low. It's in the less than 100 compared to 3,000 that you get for conventional concrete. So that's one of the reasons that really this material is very durable. And durability of the material really is one of the main reasons why we use this. It's a wonderful material for retrofit. So those of you who have not seen this slide, on the upper side, upper portion shows the UHPC, and the bottom shows the conventional concrete. When you apply the UHPC to conventional concrete, if you prepare the surface adequately, by adequate I mean you need to have an exposed concrete, exposed aggregate. That's what, for example, Sam was saying, that they sandblasted. And then the number two is that you have to make sure that the surface of the material is moist before you apply the ultra-performance concrete. And the reason for that is because ultra-performance concrete doesn't have that much water. The water cementitious ratios are in the order of 0.2, 0.18. So if you don't have, if the surface of the conventional concrete that you're going to spray over is not adequately moist, at least 24 hours before the spray, then it's going to absorb all the water, that little water that's in the UHPC, and it's going to cause a crack. Material right now, actually, FHWA defines UHPC as it must have more than a 17.5 KSI compressive strength. But in actuality, I mean, you get into on 25, 24 KSI in 28, 56 days. It's very flowable. Really, a slump doesn't mean, in the case of the UHPC, it oozes. And when you do the flow table test, I mean, for the sprayable concrete, you need to have around a 6-inch, but for the cast in place, I mean, you're looking at something close to probably 9 inches. So let me share with you some properties of the ultra-performance concrete. We are at FIU, we are conducting tremendous amount of work in the area of the ultra-performance concrete. We have developed at IBT, ABCUTC, we have developed open source UHPC for conventional applications and also for sprayable applications. For conventional applications, without going into too much detail, the cost of the material is a fraction of the commercial version that are available. And we are not the only ones that have developed the open source UHPC. University of Michigan has developed open source. New Mexico has developed, as well as a couple of other universities. So and I'm pretty sure that by time the cost of the UHPC is going to go down, and it's going as the construction industry gains confidence, I think its application is gonna increase. And one of the main reasons for the high cost of the UHPC is really the steel fibers. In 1 cubic yard of UHPC, we use about 250 pounds of steel fibers. So let me just show you some data that we have. These are small beams that is sprayed with the UHPC, and then under the 4-point loading is tested. So the surface, actually, these are some of the specimens that were prepared. The surface was prepared, the exposed aggregate, it was moist, and then it was sprayed. So no reinforcement, nothing else. And you can see that the tensile capacity in the bottom of that beam increases, or the modulus of rupture, basically, which is indication of it, is increasing by increasing the thickness. So for durability applications, I'll show you one means maybe you can decide what should be the thickness that you should apply. We've done quite a bit of a test with the direct pull-off test. So another way, we have a sprayed. We've done lots of tests. These are some of the old pictures, actually. We have applied sprayed the UHPC, and then did a direct tension test, basically, following the ASTM C1583. I can tell you that we've never seen the failure to take place at the interface between the normal strength concrete and what was sprayed. It's always at the normal strength concrete level. And the same results, actually, for cast in place have been reported by like Ben Graybill at FHWA and others. So, and that's a very good news. So you don't have to, the bond between the UHPC and the conventional concrete, whether it is sprayed, whether it's a cast in place, is very strong, is adequate. You don't have to worry about that, as long as you prepare the surface adequately when you apply the UHPC against it. These are just some of the numbers, the pull-off test that, for example, these are the stresses that we obtained, okay? 391, 410 PSI, and so on. So like I said, we never get the failure at the interface. Some data on the durability. This is others have done, FHWA, Ben Graybill has done some work, other people have done work in the area, freeze-thaw. This is a standard ASTM freeze-thaw test. These are all UHPC. This is not a spray. Right now, we are actually conducting freeze-thaw on non-standard samples. These are the samples that we are doing right now is basically conventional concrete with UHPCs applied to it, and we are going through the freeze and thaw. I don't have the data on that, but this is all UHPC after even 365 cycles. I don't have all the data here, but even after 360 cycles, absolutely no mass loss, absolutely no damage to the concrete. So the durability of this concrete is really is one of its main property. We have done some tests with we have taken basically core out of a concrete that's been sprayed, and then we have done RC rapid chloride permeability test on these, and the numbers that we are getting. This slide kind of shows you the data. For example, if I don't have anything, basically just a plain reinforced concrete, I mean the number varies depending on the concrete. I mean 2,000-3,000 psi, even some very large numbers. But if you apply just a very 0.5 inch of spray UHPC, you can see that now it's going down. When you get to the one inch sprayable or 0.75 inch, really you are looking at the 200-300 coulomb for the RCP numbers. We are also doing, I just wanted to show this slide. We are doing also some fire tests because there is some interest trying to say, okay, if an accident happens, if a fire caught in let's say in the truck caught in fire, what will happen? So we are doing some fire tests on this material. I don't have really the results to show you, but this is some of the preliminary stuff that we have seen. We have varied the percentage of the steel. Interestingly, we are seeing that the compressive capacity of the samples, these are cube samples that are cooked in an oven and then subjected to a compressive test. We are seeing that actually up to about 300 degree, if you heat it up to 300 degree for a couple of hours, then take it out of the oven and then do a compressive test, actually the strength increases. We don't quite understand the mechanism of that, but others have reported the same thing. But then after that, I mean, if you put the cubes and subject it, say, to 800, 900 degree Fahrenheit, cook it for 2 hours, and then take it out, and then do a test, of course, the strength decreases. Not shotcrete with UHPC. Now, we did quite a bit of a work in the lab, and I'm going to show you a video. Basically, you have to make sure that the aggregate is exposed. You have to make sure that the surface is wet. We have modified our equipment actually to do the nozzle and so on. And equipment is really a key in this case. Of course, the mix is important, but having the right equipment is really important because this material has lots of steel fibers, and those steel fibers plugs basically the system. But you can see here that I'm just going to show it. You can apply several layers. Like, for example, here you see that we are applying additional layers. But you have to let the first layer to a little bit dry up before you apply the next layer. If you use a right mix, the elastic rebound is really minimized per se. So, and one of the reasons actually we started this experiment back in 2018, but of course, always the question is that can you do this successfully in the field? And that was the reason why we basically teamed up with the Virginia DOT with Sam Flaha to do this project. So what we decided to do, like Sam said, originally we were gonna do only the side of the abutment with a small area of in need of the repair. So based on that, we got all the material, and we are using open source. We are using ABC UTC open source UHPC data. So this is not a commercial version. This is just basically the open source that we have developed, and we are basically we measured everything. We shipped it to the Northern Virginia near Washington DC area, and together with our equipment that has been modified. So this is the slide that Sam showed. We were originally supposed to only fix this one, and we asked them to give us also another area for practice. And what happened was actually in the field, because of like Sam said, because of the traffic control, they changed it. This became the area that we could, they allowed us to experiment one day, basically to make sure everything is working. And then the other area, which was a very large area, which we did not have enough material to fix, that became basically the final one. So on Monday, August 19, basically we sprayed this area that you see, and then on Wednesday, August 21st, we did basically the other area. Here is I'm going to show you few videos of these things, and but I'm not going to run it completely. But I hope hopefully this gives you some ideas. And by the way, it is we use the man lift, and man lift is not really a good platform for a spray. The reason for that is because sometimes when you move the man lift up and down, it really shakes, and that little shakes, I mean, that affects. So but you can see over here that we are applying, we are applying this UHPC in layer by basically layer. The larger the area is, the better off you're going to be off, because by the time you go from one end to another end, that will give you the chance to dry the material. This is the same abutment still. Because we had a limited materials, I didn't want to repair all part of this one, but on that day we did have some extra material. We said, well, let's go ahead and just add this spray a little bit to the rest of the abutment. So you can see that here. And to your no surprise, actually the nozzle man is no one other than Dr. Azizi himself. Later I learned that you have to have a certification to be a nozzle man. So I guess I was an illegal nozzle man, but nevertheless, this one I decided to do it myself because it was the first applications, and we had experimented a lot in the lab. Now here is the abutment that actually we fixed. This was supposed to be the experiment, but as you can see, it's a very large area, and you needed lots of material. But we did not. I think we took about 40 material, enough material to make a 40 cubic feet of UHPC, and you needed to do all the both abutment, all the area. You needed at least about 100 cubic feet. Okay, so more than almost little less than 4 cubic yard of the UHPC you needed, but we didn't have that much material really. So they did sandblast it, they did expose it. Now abutment, those of you know, I mean, when you design an abutment, you put a minimal amount of reinforcement. So still reinforcement really is not that critical for the abutment, especially in the non-seismic areas. And so, but we did ask them, if you want, you can put some new reinforcement, but they decided that just to have the reinforcement as is, just expose the aggregate, they wet the concrete and was ready to go. Here's another video. So as you can see, so this is after applying it. In some places, actually, we had more than 1 inch. Actually, we went back and forth, several layers. Again, the thing is that when you apply this spray, you go from one end to another. The larger the area is, it will give you a chance to the material you apply to the first region to dry up and then come back. So if you apply layer by layer, you have to let the first layer dry up a little bit. Then you go to the second layer. So this is another area. So as you can see, there is really no elastic rebound. So and finally this is another shot. And finally we applied this curing compound. It's a white pigmented, basically curing compound that we applied. Now we were super conservative with respect to curing. We applied the curing compound, we put the wet bare lap and the plastic sheet. You don't need to do that, but we decided to do that just to prevent the potential cracking and so on. Now these are the numbers, the concrete that we used for that UHPC that we used for the spray. Now this is not taken from the core sample. This is the UHPC that was used to spray. This data was provided to us by the Virginia DOT, by Sam Flaha Group. F'(C) was 18,000. The RCP was 74, basically. And this is a tension test that they did, basically, for us at the Virginia DOT. Okay. Now let me go. I want to spend a little bit time on the lessons learned. I always say, really, a sprayable UHPC, you need to approach it as a system. Now, what do I mean by that? I mean that in a system, you've got so many elements. You've got the equipment, you've got the personnel, you've got the material, you've got the operation steps that you have. Everything have to be very well organized. If one element doesn't work, the whole system fails. And probably that's one of the reasons why this thing has not been so far, basically, at least by the August, applied successfully in the field. So we were able to, in the field condition, to apply this successfully for the first time. So that's what I'm saying. It's a system. You have to be really, this is not something that you read a manual, you go in the field, and then you just apply it. It doesn't work that way. Having a trained staff is very important. You don't need too many people. If the staff is trained, you don't need too many people on the job site. In fact, if you have too many people, it becomes actually it may be harmful to the operations. And this is what I was saying, that field personnel have to have a specific responsibility so nobody steps on each other's toes, basically. And of course, one person needs to be, no, this is based on the experience that we had in this operation. I'm pretty sure that others probably could add, subtract to this list. So in the one person, of course, needs to have a overview of the other operations. For example, when the concrete is from the mixer is going to go to the pump so that you can pump it. If there is a problem, what you should do, and so on. Cleaning the equipment following the spray is very important. This material sets very fast, and you cannot. Probably, I would say the open time for this operation maybe is about half an hour, and that kind of dictates really how much material you need to fix, how much of the area, what is the area that you're going to fix, and so on. So this is a very important aspect in that respect, that the cleaning. And if you don't clean it, it's going to ruin your operation. Practice trial. If it's even if the staff is trained, the practice trial is really important. You need to have a practice trial. Maybe you get to the point that finally you say, okay, I don't need a practice because I've done so many times, I feel easier. Okay. This is important. For UHPC, this is general, not just UHPC, for the spray. If you using you have to use a mixer that can put lots of energy. If you want to use, in fact, we took all the equipment with us except the mixer, and we asked the Virginia DOT to give us basically the mixer. And the mixer was a little bit small. We couldn't mix more than the 8 cubic feet, and that was limit. Actually filled up the mixer. So the rule of thumb is, if you want to use a mixer that is used for conventional concrete, you really should not be mixing more than half the capacity of the mixer if you're using it for UHPC. Try to get a mixer that is specific for UHPC, as paddles in a format that puts lots of energy into the mix. Now we do the open source. The open source UHPC is available, but the Sprayable UHPC is not. But open source UHPC needs to be modified in order to really to use it for the sprayable, for the spray applications. Another thing you need to notice, there could be significant difference between what you do in the lab with the small mix and the mix with the large batch. You can get completely different timing for the time needs for mixing and so on. You can apply large thickness. I would say probably inch and a half. Even probably you can do more than that. No, this is very important. Contingency plan needs to be there. For example, we took extra nozzle, we took extra hoses with ourselves just in case that our nozzle gets plugged up or hoses get plugged up, so we can replace it immediately. The platform, I discussed that. And then finally, really, the sprayable UHPC is feasible. You just have to be basically make sure that you are trained, you have the trained staff, and you have the right equipment and the right operation steps. Now, let me just tell you about little bit about the future plan, and then we're gonna open it for the question and answer. Right now, actually, our future plan is we are using it for shotcrete steel culverts. So we are doing experiment. Actually, it's ready really to repair steel culverts with the sprayable UHPC. I'll show you. This is a very first time that we did that several months ago. I'm just going to show you that you can even spray the overhead. So you're going to see the this short video that I'm spraying the UHPC, and I'm going to spray just a small portion of it, but I'm also going to spray the overhead. So it's very interestingly that it sticks to the steel culverts, and the corrugation actually helps. You can't see it, but actually we do have a, there's a region there that we put some mesh actually that we shotcrete over it. So I'm trying to right now, basically I'm spraying the UHPC. And so you have to apply this material with a thin layers. So here you see the overhead. So again, right now the implementation plans are underway to implement the sprayable UHPC, because that's one of the objectives of the US DOT. And our plan actually right now is we have received the resources to actually start implement this in the field, and also train the contractors. One of the implementation is to fabricate a mobile unit that has everything that you need in order to do a sprayable UHPC. This unit probably is going to be completed within the next, I would say, 7-8 months maybe. The work is in progress. It's going to have basically the pump, the compressor. It's going to have a hydro demolition equipment in there that you can go in the field, remove the contaminated concrete to the extent that you want, basically with the hydro demolition. And then it's going to have the silos to store most of the material. Most likely the sand is going to, we just have to bring the sand on site using a local material. But things like silica fume, slag, super plasticizer, and admixtures for the spray and the water, basically they're going to be housed in the silos in the unit. It's going to have a computerized system to keep track of what is being mixed. And like I said, the mixer, the air compressor, and the pump, basically, and everything hoses and all. So this photo that I'm showing you, it is not for the spray. This is I got this picture. There are some similar units in Europe, but this is not for the sprayable UHPC. This is for the just a cast in place. But the unit that we are developing is for the sprayable UHPC. So stay tuned. Also, as part of the implementations of this technology is we are scheduled to conduct educational and basically a workshop to construction community about the sprayable UHPC. Like I said, this is not something that you can just read the manual and run with it. It is something that you really have to be trained, and that's one of the objectives of this workshop that we're going to have. I foresee that it's going to be basically a regular workshop and followed by hands-on basically experiment. So with that, that ends my presentation. So
Great. Thank you, Torad. That is really a great example of implementable technology. I can think of numerous locations in my state where this technology could really be a great solution. So thank you again for the information. We do have a number of questions that came in both during the presentation and before. Paul Lyles, the former Georgia State Bridge Engineer, will start the question and answer session. And he will be joined by Jamal Al-Qaisi, who is our valuable partner at the Federal Highway Administration's Resource Center. Paul?
Kathy, do you see my video right now or no? Is my video on?
Yes, I do see you.
Okay. All right, sorry. Okay. Because I don't.
Paul, are you ready?
I'm ready. Torad, good job. We do have some questions here, and I'll go ahead and get those. We got a number that have come in during your presentation. So let me get started.
Do you have your camera on too? I'm not seeing myself.
I'm on.
Oh, you do. Okay. All right.
Can you see me, Kathy?
Yes, I can see both Torad and Paul.
Okay.
All right. Okay. Good.
Okay.
It's just my end.
All
okay.
Right, here's one. The first one. How is the mix design different for sprayable UHPC compared to regular UHPC?
The main difference is that in the flow table, in the diameter when you put on the flow table, the diameter of basically the UHPC is about 9 inches for the cast in place. Basically, for the sprayable UHPC, you need to be around probably 6.5 or so, and we do that by adding some admixtures to it. And and you have to be kind of careful with that. Unfortunately, right now it does require some kind of experience to do some adjustment in the field. But the main difference is that the flow diameter for the sprayable UHPC is less than the cast in place. You got to be, if you're much bigger than 6.5, I mean, you could have a problem with the spray.
Okay. The next one here is, how can you test sprayability just by doing lab tests?
Could you repeat that question?
How can you test sprayability by doing lab tests? Can you just do the test, or do you really have to spray it?
No, you have to spray. The sprayable UHPC is not just a mix. Okay, having the right mix is part of the puzzle. The big part of it also is the type of the equipment that you use. So in our case, I mean, we have modified our equipment. In the nozzle, for example, the way the air flows, I mean, is important in this case. And that's why I always say it's a system. So it's not just a mix, but you have to, in the lab, if you want to experiment, you can experiment. If you are successful in the lab, it doesn't necessarily mean that you're going to be able to do it successfully in the field. Okay. But the mix and equipment and the operations are the different parts of this whole system.
Okay. What is the slump range value for sprayable UHPC?
Yeah, I said about 7 inches.
Okay. What is the minimum and maximum spray thickness you can do with sprayable UHPC?
Yeah, minimum in there you can. I mean, there is no minimum. I mean, you can just spray it. In one spray, I mean, you can get. I mean, you're going to get less than probably 1/8 of an inch, maybe a little more than that. But as I was saying, you got to spray from one end to another end. And let me. I'm gonna show my the slides here. Basically, for example, in this slide, as you can see, you got to go from, let's say, for example, from the bottom to the top. Let me go actually this area. Yeah. For example, here, you would go from the top, let's say, to bottom, or top to the bottom. Bottom to the top probably is better because that in the field works better, or doesn't really matter. But you go in a very thin layer, and then you have to have some time gap so that before applying the second layer. So, but if you apply too soon, you are not gonna be able to. The second layer may not slip with respect to previous layer. But if you give it time for the first layer to dry up a little bit, you can apply the second layer, third layer, fourth layers, and so on. So you can go up to the 1 inch if you want to. Another observation that we've had in the field, not in the field, in the lab, is that if I let a UHPC just dry up and then go and apply additional layer, actually we have done some direct tension test. The breakage is not at the interface between the, let's say, first layer of the UHPC sprayed and the second layers, which is a good news.
Okay. You mentioned that the bonding characteristics between the existing concrete and the UHPC was okay. Could you comment a little bit on that?
Yeah, I mean, it's basically, I mean, these are the, we've done a bunch of tests, and if you prepare the surface adequately, the breakage is not going to be at the interface. So the interface has a much larger tensile capacity than the normal concrete, and of course the tensile capacity of the UHPC is much higher than the normal stiff concrete. So, but the interface has a higher capacity if you prepare the surface correctly. Expose the aggregate, make sure that surface is wet before you spray the UHPC.
Okay. Have any studies been done to understand and quantify the delamination effects under compressive loads? The compression applied parallel to the bonding surface, for example, in the Virginia DOT example application?
I don't see that as a problem. We are doing some work trying to actually the delamination. We are doing some work trying to see under the freeze thaw. I mean, that they're going to delaminate or not, or under the fire. But under the applied load, we haven't done any specific study, but it shouldn't be a problem.
Okay. Let's still more on the materials things. Here's a question about the or application construction. How is the appropriate pump for spraying UHPC? And what commercial available pump do you recommend for use for lab work?
Yeah, I mean, I'm not going to advertise for any particular company, but there are two different pumps that you can use. One is a basically double acting cylinder type, basically with the cylinder. You need a very large volume if you want to use the double acting cylinders, basically type pump. And then there is an auger type that we are using an auger type, basically. Again, you have to be careful. You have to make sure that there's lots of steel fibers in this mix, and then they can clog up. The the double acting cylinder type, you don't have that problem. But again, you have to have a large volume, and usually that's not good for the sprayable kind of UHPC. But for the double acting one, I think I'm also told that's probably is better for the conventional concrete where you have a large aggregates.
Okay. Shotcrete is typically edge floated. Can sprayable UHPC also be floated to improve the finish?
Not with the steel fibers. I wouldn't do that. But what we are doing right now is the last layer we are applying basically UHPC with no steel fibers, and you can smooth that a little bit. The finished surface, I mean, you can finish it. It is not going to be as smooth as if you apply plaster, let's say, for example. But it's good enough. We didn't do that in the case of the Virginia DOT, and that was one of the SAM concerns. In that case, I just didn't want to do it because it was the first time that we were applying this. But later, I mean, we've done some work, and when we applied the UHPC without any steel fibers, you can smooth the surface, but it's not going to be as smooth as if you apply plaster.
Okay. Yeah. Is water vapor trapped underneath the layer of sprayable UHPC?
Yeah, I'm not sure what they mean by that, but if you wet the surface, I mean, the surface is wet, you spray the UHPC. I think that's what they're trying to say. No, there is nothing trapped between the two layers, the normal strength concrete and the sprayable UHPC. There is nothing trapped in there.
Okay. I think they were worried about it would continue to corrode underneath the layer. But,
oh no, the corrosion actually we've done not with spray, with the cast in place. We have placed the cast in place UHPC over a deck basically. Intentionally, we have placed the UHPC over a contaminated concrete. UHPC actually, those of you who are in a corrosion area, you know that there's something called a halo effect, where you repair one part of the structure, then you shift the corrosion other area. It doesn't happen. Halo effect does not happen with the UHPC. UHPC actually chokes the system. It doesn't let the oxygen to get in there, and we have the data that shows that actually reduces the corrosion rate decreases in the area that there was active corrosion before applying the UHPC and after applying the UHPC, but not sprayable. I don't see it. I don't expect to see a difference with the sprayable too.
okay. Another question here. Is sprayable UHPC only appropriate for substructure repairs, or could it also be applied overhead for deck repairs? In other words, on the bottom of a deck, vertically.
Yeah, good question. Very good questions. Yes, it can. It can apply to many other applications. I think you can apply to many other. I mean, a steel culvert. Just take an example of a steel culvert that I showed you. The overhead we were doing. This concrete, if the mix is right, you can. If the mix and the equipment is right, you can do overhead. And in fact, in areas like in Florida, for example, you have this jet ski that goes underneath of the bridge, and then they spray the salt water underneath of the bridge, and then you get a corrosion from underneath. And this UHPC, actually, the sprayable UHPC, I think, is a wonderful alternative for that applications.
Okay. Another question here is how long has that application been in service, or really, how is it performing? Did you get any information on it right before the presentation? It hadn't been there too long.
I was there actually in January. I went there myself, take some picture. It looks good to me. And in fact, the small one, this one, I wish I had a picture. I should have probably put. It was in a very good shape. But I plan to sometimes go down there, actually take some core samples too. But we haven't done that really.
Okay.
But in January I was there during the TRB. I went there and I saw it during the. I remember it was a snowy day too, actually. and it looked good to me.
Okay, it's 2 o'clock. I'm going to get Jamal to come on and help me. There's a whole bunch of questions we have here. Jamal, can you come in and go ahead and pick up these questions that have come in?
Oh, yes, yes. Can you hear me?
We can.
Yes, yes, we
Oh,
can.
great, a great presentation, Atrad and Sam. That was really state-of-the-art technology that would have a great future for ultra-high performance concrete. We have questions that came in during the presentation, but before I do that, there's a question came in prior. It has to do with cost.
Yeah.
Is the cost of a sprayable ultra-high performance concrete higher than typical concrete repair?
The UHPC cost is higher than normal strength concrete. That's given. But you have to keep in mind, you don't use as much, and it lasts much longer. So the cost of the UHPC is higher than the normal strength concrete, of course. Now, is there a difference between the cost of the UHPC that is used for cast in place or spray? The cost difference is very small. Is there a difference between the commercial version of the UHPC as a material and the open source? Yes. The cost of the open source UHPC is a fraction of the commercial versions. So I don't want to get into numbers, but it is, we have a cost for us, for example, but the most of the cost coming from the steel fiber. But and in this project, we use the open source UHPC, our own UHPC, and basically, and the cost of the material is the much lower than the commercial version, of course.
Great, Atrad. Now I'm going to get into the question that came in during the presentation. The first question is about rebar corrosion. They say, were there any protection added to the rebar? Because we saw some corroded rebar. Were there like corrosion resistant, for example?
Yes. No, in this case, we gave them the option to, if they want to replace it. They decided not to replace it, and I kind of agree with that. I mean, but we did not apply any admixtures. In the abutment, because of the large concrete area, really you put minimal amount of reinforcement anyway, and even that's it's more for the shrinkage than really the strength per se. But in this case, no, we did not apply any admixtures. We did not do any treatments. We did not add any additional steel reinforcement.
Good. There's a question about coatings, surface coatings. Were there any surface coatings considered for future protection of the concrete?
No. There was nothing that we had. We just sprayed the with UHPC, and then we sprayed with the curing compound. And like I said, we were super conservative.
Okay. There's a question about, I think you talked about the thickness of the sprayed ultra high performance concrete. They say how to control the accuracy of the thickness of the sprayed ultra high.
Yeah, I mean, there are a couple of ways you can do that. You can run a simple approach, a very piano wire type from one over the width of the area that you want to spray, and that can give you some guidance, okay? Or measure the thickness as you go up. But I think putting some kind of wire across the area that you want to spray, and then that will give you an idea, for example, where you are at before starting the spray. That would be probably, we didn't do that in this case, but that's something that you can do.
Oh, that's great. Now they're talking about, no, they call it shotcrete, but it's not a shotcrete, but is commercialized, and is it possible to purchase the system, the sprayable ultra-high performance concrete? Is it commercialized, and is it possible to purchase?
Yeah, I'm pretty sure that there are some entities out there that they are trying, but I can speak on what we are doing. We are trying to basically take it to the market. This thing, we have received some resources to do that, and that exercise includes basically having a unit that can go to the field and they do all the jobs, and also part of that actually is training the contractors. One of our objectives actually is to have this workshop and train the contractors so the contractors can, and our objective is it's going to involve some agreement and so on, but the hope is that we get more contractors familiar with this technology, and also part of that, of course, is going to be the sharing all the information, detailed information with respect to equipment and so on. So if you are interested, again, I hope that we have contractors with us here. If you are interested, please send me an email, and I put my email at the very end. Let me just leave it here. This is the last slide that I showed. So send me an email, because we are hoping to start this workshop within the next few months in different regions of the country.
All right, great. Now, there is a question about removal of concrete to 1 inch below the rebar, and that's usually for conventional repair or patches. Usually what they do, they remove the concrete 1 inch below the reinforcements. Yes. Did you have to, is it needed here in this application?
No, it's not. It's a good question. Actually, in some of the structure that I saw in Europe, and I was talking to some of our colleagues in Europe, if the reinforcement is part of the main load carrying capacity of the system, you need to remove the contaminated concrete, and even about ½ inch or so, maybe ½ inch, 3/4, or 1 inch beyond that reinforcement, okay? And then cast the UHPC or spray the UHPC, because again, the UHPC then will protect that reinforcement from all sides. But if it's that reinforcement is important to the structural integrity of the system, you do have to remove the contaminated concrete. It's a good exercise. I think removing that contaminated concrete behind the reinforcement and then making sure that the UHPC goes there is a better, I think, option than anything else. That was a good question, yes.
But it has nothing to do with bonding. He's referring to a good bond between the new material and the old material.
No, it's not the bonding. Actually, we have some test data with the reinforcement partially embedded in the UHPC. You get a good bonding. No, great. This is more for the durability aspect.
Now, you mentioned about the curing. You used curing compound and then plastic and also wet burlap. They're asking here, explain the curing procedure for the sprayed ultra-high performance concrete.
Yeah, what we have done is really we did, like I said, we were super conservative, okay? So we wanted to be spray with a white pigmented curing compound and then wet burlap and a plastic sheet. But I think in the field, probably it's a good idea to spray, you know, and that white pigmented, I mean, by time it goes away, I mean, washes out. But I think it's a good idea to do basically the spray, okay? And then put a plastic sheet. Put a plastic sheet over so that to keep the more moisture in. There's also, I mean, with that respect, there are some additional references with the FHWA. Ben Gray will have published some data. Take a look at the curing of the bridge deck with the cast in place. So there has been some major projects to redeck, basically with the UHPC overlay. And if someone is interested, I think the same practice can apply everywhere. The same practice that they've done for the UHPC as a bridge deck overlay.
Great. Curing of usually they have a thin bonded overlay in some cases on decks, but a lot of projects we had is just bare concrete.
Okay.
I think you touched on this one about how much bounce did you get during spraying?
Yeah, bonding, I mean, is we have not taken a core from this.
No, not bonding, but bounce of material.
Oh, bouncing. No, we did. Again, in one area, the mix had a little bit higher flow. There was some bouncing, but not much. But then I adjusted the mix on site, and we do that in the lab too. We didn't really have the bouncing back.
All right. Now, has the ultra high performance concrete spray material ever been applied to concrete noise walls?
Concrete noise wall,
which is barrier, like wall barrier.
Yes, I know that. I don't see any reason why not. I mean, you can do that, but to my knowledge, no. The Sprayable UHPC has not been really used widely right now.
That's right, but it could be used. It could be used,
of course. Yeah, as long as any concrete surface that you have, you can get exposed aggregate, and you can wet the surface. You can apply this thing. Yeah.
All right. There's a question about the surface finish. How is the surface finished? Do the steel fiber inhibit obtaining a smooth surface?
The surface conditions, we do have actually, I don't have it in the slides, but we have experimented with different surface roughnesses. As long as you have some aggregate that is exposed, or better yet, if you have some steel that is reinforced, exposed, you will get some very good bonding. And if you just make sure that the surface is wet, at least 24 hours before the application, so the moisture gets into the normal strength concrete. And what we do, we put a wet bare lap, and then we soak it. Basically, we make sure that's continuously soaked, that wet bare lap, and then that provides the moisture to the normal strength concrete. I think that's what they're asking, right? Or maybe...
No, I think they're asking about the finished surface, which is, you know how you see the steel fibers sticking out of the final.
Oh, okay. All right. Yes, I see. Yeah, the solution, if you just spray the UHPC, you're going to have some steel fiber sticking out, which is not safe. So what we do is we spray the last layer now with the UHPC with no steel fibers, and that solves the problem.
I see. That's great. That's a great solution.
Yeah.
There's another question about the final finish, and you answer that. What was the restored capacity of the sprayed abutment after repairing?
This one was more for durability. Really, it was not for restoring the capacity. This one was just for a durability, making sure that the additional damage doesn't take place because of the leakage of the moisture through the expansion joints.
There's a couple of questions that you already answered, so I'm going to skip over them. One of them has to do with the number of layers needed, and the other is about the equipment used in the repair. there is a question about, were you able to determine the amount of, also again, the rebound? You answered that question as well.
There was no, there was a one area, I should say this. There, at the very end of the day that we had some extra material at the very bottom, actually, the bottom of the abutment that we sprayed, I just kept just depositing the material, and that was not a good practice because the layers started, because I didn't give it time for the layers to dry up. I was just spraying to get rid of everything else that I had because I didn't want to ruin my equipment, and so there was a little bit of a slippage. But during the actual spray, really, we didn't have any rebounds. Again, the mix, you got to make sure that your mix, the flow is about 6 inches or so, and that is a. I will say one thing that you got to be really careful. The moisture content of the sand that you use in this mix is very important. When you go to a large batch, depending on where you take the sample of the sand, you're going to have a different moisture content. In this case, what we did, we made sure that we are using it completely dry sand. We dried it out. So if you dry it out, then you know exactly how much water do you need to add. And otherwise, if there's a moisture in the sand, it can play with you in the field.
That's good. One final question here, Aturad. Are there requirement for respirator during application? And what about the ultra high performance concrete general for future removal and contamination as well?
Yeah, that's a very good question. Don't do anything like this nozzle man, Dr. Azizi did. Okay, you have to have, now we have a really complete, there is basically a hood that it has filters the airs on the backside. Actually, we just recently have purchased those. I think you need to do that. In fact, in the field, I forgot to zip my shirt, and there was all kinds of steel fibers in my chest after the spray. So, but no, you have to be all the safety stuff. So what I did down there was not exactly someone should do. But the waste material is very important because these are we take actually all the extra material, just like a regular concrete. You put it in some kind of container, and then after a day, the solid material goes down, and then the water in top, and then you throw the solid materials. But you need to have a good system where the people who are close to a spray have to be completely protected with the air filter and things like that. Yes.
Great. Thank you very much, Aturad. Back to you, Kathy.
Thank you. Thank you to our presenters for sharing their time and their expertise with us. It was a very interesting presentation. And thank you to Paul and Jamal for your help with the Q&A moderation. One quick announcement regarding the availability of the presentation slides. We had some technical difficulties this month with getting those posted to the GoTo dashboard, but we will get those posted to the webinar archives shortly. So please check back for those later for the PDF document. And with that, we thank you all for joining us today, and the webinar is now concluded.